Okay, so we're going to be talking about base E and natural logarithms. Base E and natural logarithms go together. So anytime you take the log of something with a base of E, it's going to actually be a natural log. So here we've got f of x equals e to the x power. And so then its inverse function is f of x equals the natural log of x. Same thing with the exponential decay, f of x equals e to the negative x power is in blue. And then its inverse is f of x equals negative natural log of x. So natural logs and e are inverses of each other. Now, we are going to go from one form to the other. So I'm going to write an equivalent logarithmic equation for e to the x power equals 23. So the best way to approach this is to put in logarithmic form how we've done. So you have log, your base is e of 23 equals x. And anytime you see natural log of e, you're going to replace, log of e, you're going to replace it with natural log. So that's how we get the natural log of 23 equals x. And this is actually something you can put in the calculator and crank out a value for. So I'm going to write an equivalent logarithmic equation for e to the fourth power equals x. So I've got log base e of x equals 4. And anytime I have log base e, I'm going to replace that with natural log of x equals 4. So if I have log base e, I'm going to replace it with the natural log. All right, so what is e to the x power equals 15? So putting it in logarithmic form, I've got log base e of 15 equals x, and I'm going to replace log e with the natural log of 15 equals x. All right, e to the fourth power equals x. I've got log base e of x equals 4, and simplify it to be the natural log of x equals 4. All right, writing natural log of x equals 1.2528 in exponential form. You can go rewrite natural log of x to be the log base e of x, and that equals 1.2528. And then putting it in exponential form, I don't like how this is written. I don't like that it's backwards. Start with your base. So e raised to the 1.2528 power equals x. So I would just rearrange how it's written. All right, so the natural log of 25 equals x. I would rewrite it to be the log base e of 25 equals x. So then I would have e as my base raised to the x power equals 25. Writing natural log of x equals 1.5763. Rewrite it as log base e of x equals 1.5763. So e to the 1.5763 power equals x. So that would be B. The squiggly equal signs is approximate because it's been rounded. So that's why that's different than just a straight normal equal sign. All right, natural log of 47 equals x. So log base e of 47 equals x. So we can rewrite it as e to the x power equals 47. Which would be A. All right, so now we're going to simplify. And all of the properties for logarithms apply for natural logarithms. So here I have 4 times the natural log of 3 plus the natural log of 6. And I'm going to write it as one single, and that shouldn't say algorithm, that should say logarithm. So 4 natural log 3 can actually be written as the natural log of 3 to the 4th power because of the power property. You can pull that 4 back. And then plus natural log 6. So then when you add 2 logarithms together, you're really multiplying. So that's how we get the natural log of 3 to the 4th power times 6. And if you were to do 3 to the 4th power times 6, you would get 486. So simplified down to 1 logarithm, we get the natural log of 486. All right, writing 2 times the natural log of 3 plus natural log 4 plus natural log y. That should say logarithm. So I'm going to rewrite it as the natural log of 3 squared plus the natural log of 4 plus the natural log of y, which everything's added, so we can multiply. So the natural log of 3 squared is 9 times 4 times y, which gives us the natural log of 36y. Okay, I've got 4 natural log 2 plus natural log 3. So I can pull my 4 back and say it's the natural log of 2 to the 4th plus natural log 3. And it's addition, so I can multiply. So the natural log of 2 to the 4th power is 16 times 3. So it's the natural log of 48. All right, 3 natural log 3 plus natural log 1/3 plus natural log x. So I can say it's natural log of 3 cubed plus natural log 1/3 plus natural log of x. So it's all addition, so I can multiply. So the natural log of 3 cubed is 27 times 1/3 times x. So we get the natural log of 27 times 1/3 is 9x. Okay, solving now. So I've got 3e to the negative 2x power plus 4 equals 10. So I'm going to work to get x alone. So my first step is I'm going to work to get e to the negative 2x alone. So I'm going to subtract 4. So I get 3e to the negative 2x equals 6. Now I'm going to divide by 3. So I get e to the negative 2x equals 2. Now, had it just been e to the negative 2 power, I could have put that in the calculator. However, it's negative 2x, so I can't do that. So what I should do now is I'm going to put it in logarithmic form. So I've got log base e of 2 equals negative 2x. Anytime I see the log base e, I can rewrite it as the natural log of 2 equals negative 2x. And now I'm going to pull up my calculator. So I'm using my TI-84 calculator, and in the calculator I can put in the natural log of 2. So the natural log of 2 is 0.693, going on and on for a while. So that equals negative 2x. And my last step to solve for x is I'm going to divide by negative 2. And in the calculator I haven't rounded or anything yet, so now I'm going to put in that decimal divided by negative 2, and I end up with x equaling negative 0.347, and we round to 3 decimal places. So there we go. This says 10 thousandths, but we're just going to go thousandths place because that's what they use on the AP test. All right, so 2e to the negative 2x plus 5 equals 15. I want to work to get my e to the negative 2x alone first, so I'm going to subtract 5. So 2e to the negative 2x equals 10. Then we can divide by 2. So e to the negative 2x equals 5. Now I can put this in logarithmic form. So log base e of 5 equals negative 2x. I can replace log base e with the natural log of 5 equals negative 2x. In the calculator, I'm going to put the natural log of 5 in, and I get 1.609, and it keeps on going, which equals negative 2x. Now I'm going to divide both sides by negative 2, and then I can eventually round. So 1.609 on and on divided by negative 2 gives me negative 0.805, well, 47. So if I was rounding to the thousandths place, that would be a 5. Okay, so I'm solving 2 times the natural log of 5x equals 6. So what I can do right off the bat is to get rid of that 2, I can just divide both sides by 2. So that's how I get the natural log of 5x equals 3. Now I can put it in exponential form. So the base is e raised to the 3rd power, and that equals 5x. Now in the calculator, you can put e to the 3rd power, which is 20.086, and it keeps on going on and on and on. And then divide that by 5 in the calculator, and that's where we get 4.0171. So we're going to solve 3 times the natural log of 6x equals 12. So what I can do here is I can divide both sides by 3. So I get the natural log of 6x equals 12 divided by 3 is 4. There's not much else to do here, and I can't take the natural log of a 6x. So what I can do is I can put it in exponential form. So my base is e raised to the 4th power equals 6x. In the calculator, I can put e to the 4th, so e to the 4th power is 54.598, and it keeps on going, which equals 6x. And now in the calculator, I can divide by 6, and I get that x equals 9.0997, which is this answer choice here, but it's really 9.100 if I'm going by the thousandths. And that is it for our base E and natural log notes for today.